We are given trapezoid ABCD, where AD and BC are parallel, and AB and AD are both 5 units long. So we draw ourselves a picture and we label everything as you see here. And the problem also says that BD is 8 units long. So BD is the diagonal going from here to here. And it's 8 units long and bisects angle ABC. We are told also that BC is 20 units long. And we are told to find the area of trapezoid ABCD. So the area for a trapezoid is you take the average of the two parallel lines and then you multiply that by the height. So we don't know the height for sure. We have a diagonal height of 5 over here, but we do not know the altitude, the vertical height. So we need to find that. So in order to do that, we're going to construct ourselves a square right here, and we're going to construct a diagonal that goes from A to that other point we just created. We'll call that point E. So now we are also told, remember, that BD is 8 units long. Now a rule that we know to be true with parallelograms is that the diagonals will bisect each other. So if BD is 8 units long, that means this right here must be 4, and this right here must be 4 as well. So now we have two sides of a triangle that are 4 and 5. So the third side we can assume to be a 3. So we have our special 3, 4, 5 triangle. So that's going to be 3 units long, and then this right here would also be 3 units long because of the same reason. And when we constructed the square, it's a square, so now that's going to be 5 units from B to E, and this over here, DE, is going to be 5 units as well. So we kind of improvised a little bit and drew ourselves a picture. So if BE is 5, we can also say that EC is going to be 15 to give me that 20 total. So we need a little creativity here, and we're going to find the area of this entire rhombus. It's not really square, I shouldn't have said that, it's a rhombus. And we're trying to find the area of that entire thing. But to do that, we cannot just say, we cannot just take 5 times 5 right there, the base times the height, because this is not a true height. The height needs to be perpendicular. So what I need to do is actually find the area of this triangle here, then multiply by 2 to get the area of this triangle here, and then go from there. So what we have is our formula for area of a triangle is 1/2 base times the height. The base is right here, 4 and 4, or 8 total. So 1/2 times 8 times the height. The height is 3, so that's going to give us 12. And then multiply that by 2 to get the area of the entire rhombus right here. So that's going to give us 24. So that's the area of the entire rhombus. Now the area of the rhombus is base times height, but the height is the vertical height. But I can use this to find the vertical height. So I have 24 is our area equals base times height. So our base we already know to be 5 times the height is what we're looking for. So 5 times h. So h we can actually find to be 24 over 5. And now we're going to use this to find the area of the trapezoid. Area of the trapezoid, remember, is the average of the top and the bottom, the bases, the two bases. So right here, 20 and 5, the average of that. So that's going to give us 25 divided by 2 is our average, times our height, which we just found to be 24 over 5. So we multiply those two together. We're going to get 1 and 5. So 24 times 5. And actually the 2 and the 24 can reduce as well. So I'm going to be left with 5 times 12 on the top, which is going to give me a 60. And that is my area of the trapezoid.